Example number 3. Combine vertical and horizontal shift. Use the graph of f of x equal absolute value of x to graph the graph of g of x equal absolute value of x plus 3 minus 5 using transformation. So to do this, you first start with f of x equal absolute value of x. You can make the table for this, but you cannot make the table for g of x. But instead of that, from the f of x, we will move up or down, left or right to get g of x. Step number 1, we graph f of x equal absolute value of x. You go back to the library of function, the table, and you see that the graph of f of x equal absolute value of x look like this. We can make 5 points in order to see the complete nice graph. However, for this section, the minimum you can only do 3. I will make negative 1, 0, and 1. And then we put in negative 1 into the function, so we get 1, absolute 0 is 0, absolute 1 is 1. We plug the 3 points in the graph. So 0, 0, 1, 1, and negative 1, 1. So we get this graph, and that's it. And this is the function f of x equal absolute value of x. Now we're going to show the transformation. Before we do the transformation, let's review. If we have f of x plus k, then k will tell you up or down. If it's positive, it's up, and if negative, it's down. And we have f of x. In the book, we use the minus better, okay? F of x minus h. H is inside. If the h is positive, you're gonna go to the right. And negative, you're gonna go to the left. So k outside tell up and down, h inside tell you left or right. In the problem, we have a number 3 and number 5. Which one is the inside and which one is the outside? Look at the absolute value. The 3 is inside the absolute value. The way for us to check is that you will begin from the function f of x equal absolute value of x. Now let's change the inside to x plus 3. Then you will get absolute of x plus 3. And you see this is exactly the function g, right? And then we will minus both sides a negative minus 5 both sides. So we get f of x equal f of x of x plus 3 minus 5 equal x plus 3 minus 5. So this part is the function g. So the function g will have the same graph as the function f, but it will move 3 units. In the formula is a minus. So this is the same thing as x of minus negative 3. So the h is negative. So you gonna go to the left 3 steps. And 5 minus 5, you will go down. So you see that the plus, but it's a negative 3, so we go to the left, okay? So don't get confused with the step. The example number 2, you see that it's a plus 2 right here. Plus 2 right here is same thing as x minus negative 2. So negative 2, so it's moved to the left. So function h moved to the left 2 steps. Okay, so from this, you can make the same in the same graph, or you can draw the other one. So in this case, we first learning, so I'm gonna do separate. Okay, to be easy, I'm gonna label the point. I'm gonna call this point is like A, point B, and point C. Now I'm gonna do both steps at the same time. That means I will go up, down, and left, right at the same time. Okay? So if we move the function to the left 3 steps, the point will move like this. The point B will land on here. So this is the point B. And then the point C will land on here. The A will land on here. So it will be like this. So it's moved to the left 3 steps. And then from that 3 steps, we will move 5 down. So the point B go 5 units down. So it will land on -5. So the point B will be here. The point C down 5 steps. The point A down 5 steps. So this is the function G, and that is our final answer. So this is called transformation process to get the graph without making the points.